Okay, so we're going to talk about the slope of a line and what it means and how to find it. So first thing I need to do is define slope for you. So slope really describes the steepness of the line, okay? And that doesn't tell us how to find it. That just tells us what it looks like. So when I think steepness, I think about a hill. So if I'm going uphill, my pen will write. This line compared to this line, the second one has a steeper slope, so it has more of a slope, okay? So we'll worry about that a little more in just a minute. But I want you to think about how we find the slope. And so what we do, slope is defined as the change in y divided by, or as a ratio of, the change in x, okay? So that's why sometimes it's referred to also as the rate of change, because it's how much is it changing over time. So it's change in y divided by change in x. So I'm going to give you a little formula too, but I want you to be familiar with rate of change, okay? All right, so here's how we find it. If it's the change in y divided by the change in x, then what I do, if you think about 2 points, any 2 points, okay, we'll call them x1, y1, and x2, y2. Then what we do is we subtract the y's on top, because it's the change in y, and we divide it by the change in x, so we'll subtract the x's on the bottom, okay? So this is your general formula for slope with variables, but of course a lot of times it's easier if we do it as an example. So let me show you an example here. If I have the point -2, 0, and 3, 3, and I'm asked to find the slope between those 2 points. The computer's wanting to act slow today. So what I want to do, remember slope, and we're going to let m be slope. Okay? Remember the formula, it's y2 minus y1 over x2 minus x1. Okay? And it doesn't matter which ones you let be 1 and which ones you let be 2. I'll just label these just so that you can kind of see where the numbers are coming from here. I'll do the first point as x1, y1, and the second one is x2, y2. So what I'm going to do is to find the slope between these points, I'll take the y, so 3 minus 0, oh, I'm sorry, divided by, and now I'm going to do the x's. So 3 minus, and this time it's -2. Be very careful because the signs are what's going to throw you if anything does, okay? And so we get 3 minus 0 is 3. 3 minus -2, if we do same, change would give me 5, okay? So the slope of that line would be 3/5. Okay, so these 2 points, if I were to graph them, -2, 0, and 1, 2, 3, 1, 2, 3. If I were to connect these into a line, the slope of this line would be 3/5, okay? That means the change in y divided by the change in x, every time y increases 3, x increases 5, okay? So 3/5. Let's practice one more. Let's find the slope between, if for -2 and negative 2, 6 are 2 points on a line. Find the slope of that line. So here's what I want to do. I want to do the difference in the y's divided by the difference in the x's. Okay? So here I'm going to do 6, because that's my y, minus negative 2 divided by negative 2 minus 4. Again, I'm going to do my same change, change, same change, change. So up top, I get 8, and on the bottom, I get negative 6. Now, of course, you know that I can reduce this fraction, so they're both divisible by 2, so I can reduce this to, and a positive divided by a negative means that my fraction's just going to be negative, so I get negative 4 over 3. All right, what this looks like when I graph. If I start at 4, 1, 2, 3, 4, negative 2, okay, and negative 2, 1, 2, 3, 4, 5, and 6, and I'm almost out of room here, I apologize. And I connect these. The slope of this line is negative 4/3. Now notice the difference in what these look like from the last one. The last one was a positive slope. This one is a negative slope, and so they look a lot different. And I'm going to go back for just a second to the other one. Okay, so if you notice this line with the positive slope, it looks like it's going uphill, and that's because that's what a positive slope looks like, okay? And remember this change in, this change in y divided by the change in x. So here, from one point to the next, I'm going up 1, 2, 3, and I'm going over 1, 2, 3, 4, 5, which is where my 3/5 comes from, okay? As opposed to this line, the second one we did, which looks like a negative slope, it looks like it's going downhill. Okay, so downhill means that my change is negative. All right, so from one point to the other, I'm going down 1, 2, 3, 4, 5, 6, 7, 8. So I went down 8. And I'm going over 1, 2, 3, 4, 5, 6. Okay, so that's where that 8 and 6, we just reduced it to negative 4/3. But I really want you to see the difference in the negative slope and the positive slope. Okay, let me give you one to try now. And I want you, for these 2 points, I want you to find the slope of the line that passes through these 2 points. So if you'll just take a minute and find that slope. So I hope you had a chance to find the slope. We're going to check it, do it together. So I subtract my y's, which is 9 minus negative 1, and I divide it by the difference in the x's, which is 5 minus negative 4. If I do a same change, change, again, I get 10 over, same change, change, 9. Okay, so this is a positive slope. It's 10 over 9, which means the y is changing, going up 10 and over 9. So it's going to be a positive slope that looks something like that. Okay, let's try one more. Let's find the slope between the points negative 2, 5 and negative 7, 8. I hope you've had a chance to work this one out. Let's do it together. The slope, we're going to subtract the y's, and we're going to divide it by negative 7 minus, always subtract, negative 2. Same change would give me 3. Same change would give me 5. So the slope of this line is 3/5. And actually, negative 3/5, I apologize. Okay, let's talk about some special lines here. We talked about a horizontal line versus a vertical line. So we often said when the line is in the form like y equals 2, okay, that's a horizontal line at 2. So the question becomes, what does the slope of a horizontal line look like? Well, let's pick two points off the line and let's calculate the slope. So let's pick, we'll do 0, 2, and let's do, I'm just randomly picking 2 points, 3, 2. Okay? Those are both points on that line. So when I find the slope here, I do subtract the y's and divide it by 3 minus 0. Now up top, I get 0, and on the bottom, I have any other number, right? Well, 0 divided by anything is just 0. So write somewhere here, all horizontal lines have a slope of 0 because the y never changes. This value up top, when you subtract the y's, all the y's are going to be the same because y always equals 2. That's why it's a horizontal line. So the slope of all horizontal lines is 2. Okay? All right, let's look at vertical lines. Vertical lines, remember, are x equals some number. So let's just say, for instance, x equals 1. We'll say the line x equals 1. So for this one, all the x values are the same, right? We've got a horizontal line at 1. This is the line x equals 1. So if I want to find the slope here, let's just pick 2 random points. Let's say 1, 1. And we'll actually go down a little bit. Let's do 1, negative 2. Okay, so when I find the slope, I subtract the y's, negative 2 minus 1. And then I subtract the x's. But look what happens. That x is always the same. And if it's always the same, that means when I subtract it, I'm always going to get 0. Now, if you think about this, when you divide by 0, you get something. I can't divide by 0, right? I get an undefined line, okay? So all, or an undefined value, I can't divide by 0. So all vertical lines always have an undefined slope. Okay? All right, so I want you to think for just a minute, and just as a recap, think about horizontal versus vertical lines in terms of slope. Okay? Horizontal, the slope is 0. Vertical, the slope is undefined. Okay? Now, let's take a minute to talk about rate of change for just a second, because rate of change is really the exact same thing as slope. It's just when we apply the concept of slope, we start talking about rate of change. Okay, so let's say that I have water evaporating from a swimming pool, and every hour it evaporates at the same rate. Okay, so let's say after 2 hours, 4.5 gallons has evaporated, and after 6 hours, 13.5 gallons has evaporated, and after 12 hours, 27 gallons has evaporated. So what I want to do is I want to find the rate of change, the rate at which the water is evaporating. Okay, so what I want to do is I want to find the slope between any 2 points on this here. I want to find the slope. So what I do is I let time be x and I let gallons be y. Okay, and I just subtract, pick any 2 points. I'm going to work with these first 2 points here. 13.5 minus 4.5, and I'm going to divide that by 6 minus 2. Okay. 13.5 minus 4.5 is 9. 6 minus 2 is 4. So what that means, since this is 2.25, it means the water is evaporating at a rate of 2.25 gallons per minute. Okay? Let me give you one to try. Let's say that you are at the gym working out, okay? And you burn so many calories per minute, right? And let's say that it's a linear relationship. If I give you the time you work out and the calories burned, I want you to find the rate at which you burn those calories. So let's say in 40 minutes, you burn, well, 500 calories. 60 minutes, you burn 750 calories. Find the rate of change at which you burn calories. So when we find this slope, we'll let this be x and this be y. We'll have 750 minus 500 divided by 60 minus 40, because those are my x's. 750 minus 500 is 250. 60 minus 40 is 20. So I get 25 over 2, which is 12.5 calories per minute. And that is rate of change.